Hello everyone, in this video we're going to focus on huge transit polar MCQs that most tested on the apcalculus PC exam. Alright, before we're going to dive into the question, let's review some concepts behind this topic. Let's get started. Number one, we're going to talk about the position. Excavate R of t equals S of t, Y of t. Number two, we're going to talk about the velocity. Excavate V of t equals ds over dt, dy over dt. Or sometimes we're going to write this one as S prime of t, Y prime of t. Number three, we're going to talk about the speed. The speed is the magnitude of the velocity vector, so it could be absolute value of V of t. So it could be square root of ds over dt altogether square plus dy over dt altogether square. Number four, we're going to talk about the acceleration vector. A of t is the second derivative of the position, right? Or sometimes we can rewrite this one as S double prime of t, Y double prime of t. 5. The total distance traveled by position vector is given by is also the arc length of a parametric curve. Now, number 6, we're going to talk about the magnitude of the displacement of the object over the time interval t1 to t2. We need to calculate delta F equals integral from t1 to t2 of ds over dt times dt, right? Delta y is going to be integral from t1 to t2 of dy over dt times dt. And displacement magnitude is absolute value of delta r equals square root of delta s square plus delta y square. Now next one, number 7. You need to memorize the following conversions. S equals r cosine theta, y equals r sine theta, right? Now if I'm going to square this one, it's going to be s square equals r square cosine square theta, y square equals r square sine square theta, right? If I add this guy up, it's going to be s square plus y square equals r square, right? And remember, tangent theta equals y over s. Number 8, we're going to talk about the dy over ds equals dy over d theta divided by ds over d theta. Basically, you just divide the top bottom by d theta. Now, number 9, the error enclosed by a polar curve. It's going to be a equals 1/2 integral from a to b of the radius square d theta. Now, number 10, the error between two polar curves. It's going to be a equals 1/2 integral from a to b of the outer radius square subtract the inner radius square d theta. Now be careful, you're not going to write this way 1/2 integral from a to b of outer radius subtract inner radius altogether square d theta. This one is completely wrong, so keep that in mind. Now let's move on to question 1. The position of a particle moving in the xy plane is given by parametric equations. S of t equals this guy, while t equals this guy. What is the slope of the tangent line to the path of the particle at the point where t equals 2? So we need to calculate dy over ds and then evaluate this one as t equals 2, right? So in order to do this one, we need to borrow dt, right? So we have h prime of t equals ds over dt, right? It's going to be sit times t plus 1 subtract sit t over t plus 1 altogether squared, right? So it's going to be sit over t plus 1 altogether squared, right? Y prime of t equals dy over dt. It's going to be minus 2t times negative 8 over t squared plus 4 altogether squared, right? So it could be 16t over t squared plus 4 altogether squared, right? We're going to evaluate this one as t equals 2. So it's going to be 6 over 9, right? It's going to be 2 over 3. Evaluate this one as t equals 2. It's going to be 32 over 64 is going to be 1 over 2, right? So finally we have dy over ds equals dy over dt divided by ds over dt. So it's going to be 1 over 2 times 3 over 2. It's going to be 3 over 4. The answer is C. Now let's move on to question 2. At time t greater than equal to 0, a particle moving in the xy plane has velocity vectors given by this guy. What is the total distance the particle travels between t equals 1 to t equals 3? Alright, so we just calculate the integral form 1 to 3 of square root of 4 e to the negative t altogether square plus sine of 1 plus square root of t altogether square, right? dt. Now we're gonna bring up the calculator. We're gonna add calculator, hit the button right here, input the integral. Integral form 1, 2, 3. Press Control Enter. It's gonna be 1.860. Now question 3. A curve is defined by the parametric equation s of t equals this, y of t equals this. What is the second derivative in terms of t? We have dy over ds equals dy over dt divided by ds over dt, right? Now we're going to take derivative of this one. It's going to be 3e to the 3t divided by 6e to the 2t. And if we simplify, it's going to be 1 over 2e to the t. Now we're going to take the second derivative. So we have d squared y divided by ds squared. It's going to be d over dt of dy divided by ds divided by ds over dt. Now the derivative of this one with respect to t is going to be itself, right? So we have 1 over 2 e to the t divided by derivative of s with respect to t is going to be 6e to the 2t, right? Now we're going to simplify this one. It's actually 1 over 12 e to the t, right? So the answer must be A. Question 4. For time t greater than equal to 0 seconds, the position of an object traveling along a curve in the xy planes is given by the parametric equation s of t, y of t, where ds over dt equals t squared plus 3. dy over dt equals t cubed plus t. At what time t is the speed of the object 10 units per second. Alright, so we know that the speed is, so it's gonna be square root of t squared plus 3 altogether square plus t cubed plus t altogether square equals 10, right? Now we're gonna bring up the calculator. We just graph these two guys on the same x-y coordinate planes and we're gonna find intersection, right? So we're gonna go to home screen, hit graph right here. f1 of s should be square root of, enter. It's gonna be right here. Alright, now press tab. Number 2, we're gonna hit 10, right? Press enter. It's gonna be right here. You know that t is greater than or equal to 0 seconds, right? So basically, the intersection should be on the right hand side right here, right? Press menu, number, shift number 4, go to the left, go to the right. It's gonna be 1.81. Now question 5. A particle moving in the xy planes has velocity vectors given by v of t equal this one. For time t greater than or equal to 0, what is the magnitude of the displacement of the particle between t equals 1 to t equals 2? Alright, so we need to calculate delta s is going to be integral from 1 to 2 of s prime of t dt, right? Integral from 1 to 2, s prime of t is given by right here, right? Now delta y is integral from 1 to 2 y prime of t dt. It's going to be integral from 1 to 2 of 5t squared dt, right? Absolute value of delta r equals square root of delta s altogether square plus delta y altogether square, right? So we're gonna print up the calculator. Alright, so we're gonna hit the square root side first, right? Delta s squared, but delta s equal this one, right? So we're gonna hit the put it right here, input the integral from 1 to 2 of e to the sine t. We hit control enter. It's gonna be 11.953. Now question 6. The position of the particle moving in the xy planes given by the parametric equations s of t equals this, y of t equals this, at which the following points s and y is the particle at rest. So you know that when the particle is at rest, it means the velocity vector is s prime of t, y prime of t equals 0, 0, right? So s prime of t is 3t squared minus 6t equals 0, right? So then t equals 0 and t equals 2, right? Y prime of t is 12 minus 6t and then t equals 2. Now look at the common thing between s prime and y prime. It's going to be t equals 2, right? So at t equals 2, then s of 2 is 2 cubed minus 3, 2 squared, right? And it's going to be negative 4. Now y of 2 is 12 times 2 minus 3 times 2 squared, right? So it's going to be 12. Then finally, sy is negative 4, 12. The answer must be A. Question 7. A particle moves on a parametric curve described by the parametric equation s of t equals 3t plus 1. while t equals 2 plus t cubed, which our proponent gives the length of the particle from point 1, 2, 7, 10. So from this point right here, which means f of t equals 1, it tells us that 3t plus 1 equals 1, right? And then t equals 0. Y of t equals 2, right? And then 2 plus t cubed equals 2. And then t equals 0. Now the second one, s of t equals 7 right here. Then 3t plus 1 equals 7. And then t equals 2. Y of t equals 10. And then 2 plus t cubed equals 10. And then t equals 2. So finally, you have the interval from 0 to 2 to move from this point to this point, right? Now to find the length of the particle, we need to find the first derivative, right? So we have s prime of t equals 3, right? Y prime of t equals 3t squared, right? So the length is the interval from 0 to 2 of square root of s prime t squared, right? So it could be 3 squared plus y prime of t squared. It's going to be 3t squared altogether square dt, right? So we're going to simplify this one. It's going to be integral from 0 to 2 square root of 9 plus 9t to the 4 dt. So the answer must be A. Now let's move on to question 8. If s equals ln 2t and y equals t cubed plus 1, what is the second derivative of this guy in terms of t? Alright, so we have dy over dx. It's going to be dy over dt divided by ds over dt, right? Dy over dt is going to be 3t squared. ds over dt is going to be 2 over 2t, right? If we simplify, it's going to be 3t cubed, right? Now we're going to take the second derivative, right? So we have d squared y divided by ds squared. It's going to be d over dt of dy divided by ds over dt, right? Now we're going to take the derivative of this one with respect to t. So it could be 9t squared. And ds over dt is going to be 2 over 2t, right? So if we simplify this one, it's actually 9t cubed. The answer must be D. Now question 9. The position of a particle moving in the xy plane is given by the parametric functions s of t and y of t, for which s prime equal this, y prime equal this. What is the rate of change of y with respect to s when t equals 2? So it's the same thing as we need to calculate dy over ds at t equals 2. So we're going to divide the top bottom by dt, right? So we have dy over dt divided by ds over dt, right? At t equals 2. So it could be dy over dt is right here. ds over dt is right here. Evaluated at t equals 2, right? So we're going to bring up the calculator. Hit the button right here. Input this fraction. Press Ctrl Enter. It's going to be negative 1.802. So the answer must be A. Question 10. The position of the particle moving in the xy plane is given by the parametric equation. S of t equals this, y of t equals this, where n is a positive constant. If the line s plus 2y equals 6 is parallel to the line tangent to the path of the particle at t equals 4, what is the value of n? Alright, so you need to find the slope, right? So we have s prime of t is n times e to the n t, right? Y prime of t equals negative 3 over t minus 1 altogether square, right? So this one, derivative of 1 over u is going to be negative 1 over u square. So you have dy over dx equals dy over dt divided by dx over dt. So it will be negative 3 over t minus 1 altogether square over n times e to the n t, right? Now you need to evaluate this one at t equals 4, right? So it's going to be negative 1 over 3 times n e to the 4n, right? And this tangent line parallel to this line, right? So they have the same slope, right? The slope of this guy is negative 1/2, right? So we're gonna let this one equals negative 1 over 2. This guy is the same thing as 3n times e to the 4n equals 2. Now we're gonna write these two lines on the calculator. So we're gonna go to home screen, hit graph right here, hit tab, go up to F1. I'm gonna clear this one. Put 3s times e to the 4s. Press enter. The second one, you're gonna hit tab, go to the second function, press 2, hit enter. It's going to be right here. Alright, now we need to find the intersection right here, right? So press menu number, set number 4, go to the left, go to the right. It's going to be 0.248. The answer is B. Now let's move on to question 11. A particle moves in the xy plane with precision given by this guy. In which direction is the particle moving as it passes through the point 11, 6? Now, in order to find the direction the particle moving, we need to find the first derivative, which is velocity, right? So we have s prime of t equals 3, right? Y prime of t equals negative 4t, right? Now we need to solve for t given this coordinate point, right? Substitute this guy over here to solve for t, right? So we have 3t plus 5 equals 11, right? And 14 minus 2t squared equals 6. So t equals 2, right? So then we have s prime of t equals 3 and y prime of t, substitute 2 over here, we have negative 8, right? This guy is positive, this guy is negative, right? Now look at the s and y coordinate right here, right? The y-axis, the s-axis. This guy is positive, this guy is negative, this guy positive, and this guy negative. S prime positive is moved to the right. Y prime is negative is moved down. So the answer must be B. Now let's move on to question 12. A particle moves on a plane curve so that anytime t greater than 0 its s coordinate is t cubed minus t and its y coordinate is 2t minus 1 cubed. The acceleration vector of the particle at t equals 1 is. Alright, so basically we need to find the second derivative of this guy, right? So we have s of t equals t cubed minus t, right? And then s prime of t equals 3t squared minus 1, right? So s double prime of t equals 6t, right? And then you need to evaluate this one at t equals 1, right? So it could be 6. Now y of t equals 2t minus 1 cubed, right? And then y prime of t is 3 times 2t minus 1 squared, times 2, right? So it's going to be 6 times 2t minus 1 squared, right? Then y double prime of t is 12 times 2t minus 1 times 2, so it could be 24. Now we need to evaluate this one at t equals 1. So it's going to be 24, right? So the acceleration a of t is 6, 24. So the answer must be E. Now let's move on to question 13. A curve in the plane is defined parametrically by the equation S and Y. An equation of the line tangent to the curve at t equals 1 is, alright, so we need to calculate dy over ds at t equals 1 is how much, right? This one is the slope of the tangent line. And then we need to use the point slope formula to write equation, right? So first I need to find the coordinate of the point, right? So I have S, Y is, substitute 1 for t over here. It's going to be 2, right? Substitute 1 for t over here. It's going to be 3, right? We have S prime of t is 3t squared plus 1, right? And y prime of t is 4t cubed plus 4t, right? So dy over ds is the same thing as dy over dt divided by ds over dt, right? Now dy over dt is going to be 4t cubed plus 4t divided by ds over dt is going to be 3t squared plus 1. Evaluate this one as t equals 1, right? So substitute 1 for t is going to be 8 over 4 is going to be 2, right? So the slope is 2, so equation should be y equals 2 times s minus 2 plus 3, or 2s minus 1. Now let's move on to question 14. In the xy plane, a particle moves along the parabola y equals x squared minus s with a constant speed 2 square root 10 units per second. If ds over dt greater than 0, what is the value of dy over dt when the particle is at a point 2 and 2? Alright, so we have dy divided by ds by taking the derivative of this one, right? So it's going to be 2s minus 1. Now we're going to divide the top bottom by dt, right? So we have dy over dt divided by ds over dt equals 2s minus 1, right? And dy over dt equals 2s minus 1 times ds over dt. Then ds over dt equals 1/3 dy over dt. Now we're going to use the speed right here. So the speed is the square root of s prime of t altogether square plus y prime of t altogether square equals 2 square root 10, right? Now we're going to square both sides and we substitute ds over dt, dy over dt over here, right? So we have, so it's going to be 10 over 9 dy over dt altogether square equals 40, right? So then dy over dt equals 6. The answer must be D. Now let's move on to question 15. The position of a particle moving in the xy plane is given by the parametric equations s and y. For what values of t is the particle at rest, which means velocity equals 0, right? Velocity is going to be s prime of t, y prime of t, right? So when I take the derivative of this one, it's going to be s prime of t equals 3t squared minus 6t, right? let this one equal to 0, right? So then you have t equals 0 and t equals 2. Now y prime of t is 6t squared minus 6t minus 12, right? And then you're going to factor 6 out. So we have t squared minus t minus 2, right? It's going to be 6 times t minus 2 times t plus 1, right? Now we're going to let this one equal 0, so t equals 2 and t equals negative 1, right? Look at the common term right here, t equals 2 and t equals 2 right here, right? So the answer must be C. Now question 16. If f is a vector value function defined by this guy, then the second derivative of this one. So we need to find the first derivative, right? It's going to be negative e to the negative t, negative sine t, right? Second derivative is going to be e to the negative t, comma, negative cosine t, right? So the answer must be E. Now let's move on to question 17. A particle moves in the xy plane so that its position at any time t is given by s of t equals t squared, while t equals sine 4t. What is the speed of the particle when t equals 3? Remember, absolute value of v of t equals square root of s prime of t altogether square plus y prime of t altogether square, right? So we need to calculate s prime of t equals 2t, right? And evaluate this one as t equals 3, so it could be 6, right? Y prime of t is 4 cosine 4t. And then you need to evaluate this one as t equals 3, so it could be 4 cosine 12, right? Now, the magnitude of the velocity is going to be the speed. It's going to be square root of 6 square plus 4 cosine of 12 altogether square. So we're going to bring up the calculator. Let's control enter. It's going to be 6.884. The answer must be C. Now question 18. What is the slope of the line tangent to the polar curve r equals 1 plus 2 sine theta at theta equals 0? Right? So we have dy divided by ds is the same thing as dy over d theta divided by ds over d theta, right? We have s equals r cosine theta, but r equals this one, so it could be 1 plus 2 sine theta times cosine theta, right? Y equals r sine theta, so then it's going to be 1 plus 2 sine theta, right? So it's going to be 2 cosine theta times sine theta plus cosine theta times 1 plus 2 sine theta, right? Over 2 cosine theta times cosine theta minus sine theta times 1 plus 2 sine theta. Right, we're going to evaluate this expression at theta equals 0, right? So sine of 0 equals 0, right? Sine of 0 equals 0, cosine of 0 equals 1, so the top is 1. The bottom, cosine of 0 equals 1, so it's going to be 2, so it could be 1/2, right? So the answer must be B. Now let's move on to question 19. The figure above shows the graphs of the polar curves r equal 2 cosine 3 theta and r equal 2. What is the sum of the errors of the shaded regions? Alright, so the error of the shaded region equals the error of the circle. Subtract the error of the rows, right? Since the rows passes the origin, which means the radius equals 0, right? So we're gonna let 2 cosine 3 theta equals 0 is the same thing as cosine 3 theta equals 0, right? 3 theta equals n pi over 2, right? N could be positive, could be negative integers, right? So theta equals n pi over 6, right? So if n equals negative 2, we have negative pi over 3. N equals negative 1, it could be negative pi over 6. N equals 0, it could be 0. And n equals 1, it could be pi over 6. N equals 2, it could be pi over 3, right? So this guy actually pi over 6 and negative pi over 6, right? The error of the rows equals 1/2. The interval from negative pi over 6 to pi over 6 of 2 cosine 3 theta altogether square d theta, right? Since number 19, we are allowed to use the calculator, but you could solve this one without using the calculator. Remember, you have the cosine square theta is equal to 1 plus cosine 2 theta divided by 2, right? So this one is 3 theta. This guy must be 6 theta, right? So keep that in mind. You have sine square theta is equal to 1 minus cosine 2 theta divided by 2. So keep that in mind. Now I'm going to hit the button right here, input the interval from negative pi over 6 to pi over 6. And then press Ctrl Enter. It's going to be 1.047. Now since this one is just the error of one pedal, right? We have 3 pedals, so we need to multiply by 3, right? So the error of the shaded equals the error of the circle, which is pi r squared when r equals 2 right here. So it could be 4 pi subtract 1.047 times 3, right? So we're going to print up the calculator, press Ctrl Enter. It could be 9.425. So the answer is D. Now we have the second way to calculate the error of the rose curve right here. And I believe that most of you will make a mistake. You're going to do like this. Error equals 1/2 the interval form. You see that this is 0 and then it's go back to the full circle. So it can be 0 to 2 pi of 2 cosine of 3 theta altogether square d theta. Unfortunately, this is not the case. If you integrate from 0 to 2 pi, you are technically calculating the error of the rows twice. This is why for any rows r equals a cosine of n theta, where n is odd, we use the interval 0 to pi to capture the error exactly once. Why? We look at this one right here. We start from the angle theta equals 0 to pi over 6 right here. Right? We trace the top half of the first pedal. Right? Now, from pi over 6 to pi over 2, it's going to be right here. Right? We get this guy. So then, observe that if the radius is negative, you're going to plot the point in the opposite way, right? So you don't see anything right here, which means the radius is negative. You're going to trace the second bevel in the lower left quadrant, right here, right? Now, next, from pi over 2 to 5 pi over 6, it's going to be right here. The radius is still positive, right? Because it's still right here. We're going to trace the third bevel in the upper left quadrant. So the error of the shaded region equals the area of the circle, which is 4 pi. Subtract the area of the rows right here. It's going to be 1/2 the integral from 0 to pi of 2 cosine 3 theta altogether square d theta. We don't need to multiply by 3 because you already calculate the whole thing, right? So the answer is still 9.425. You can check with calculator, right? By the way, I'm going to compare between rows curve with the odd end and the even end. Now for this one, we have 3 petals. This one we have 4 petals. This one full trace from 0 to pi. This one full trace from 0 to 2 pi. The error is calculated by this formula. 1/2 times integral from 0 to pi the radius square d theta. This guy 1/2 times the integral from 0 to 2 pi r square d theta. So keep that in mind. For this one right here, you can calculate the error of one petal using the formula 1/2 integral from negative pi over 4 to pi over 4 times 2 cosine 2 theta altogether square d theta. Then you're going to multiply by 4, right? Because you have 4 petals, right? Move on to question 20. The function f of theta equals this guy. Satisfy f of theta greater than equal to 0 for theta greater than equal to 0 during the time interval t between 0 to 2 pi seconds. A particle moves along the polar curve r equals f of theta, so that at time t seconds, theta equals t. On what intervals of time t is the distance between the particle and the pole increasing? So when it's come to increasing or decreasing, we're going to take the first derivative, right? We have r of theta equals to theta cubed minus 20 theta square plus 50 theta, right? And then we're going to find dr over d theta. It's going to be 6 theta square minus 40 theta plus 50. Now we're going to factor 2 out. So we have 2 times 3 theta square minus 20 theta plus 25, right? Now we're going to factor this trinomial. So it could be 2 times 5. 2 number multiply equals 75. Add up to negative 20. Negative 15 and negative 5, right? So we have theta minus 15 times theta minus 5, right? Now, since the coefficient right here is 3, you need to divide this guy by 3, divide this guy by 3, right? So we're going to simplify this one. It's going to be 2 times theta subtract 5, multiply this one because you cannot simplify, right? 3 theta minus 5. This one is the final factor form, right? Now we're going to let dr over d theta equals 0. And then theta equals 5. Theta equals 5 over 3, right? We're going to draw the number line. We're going to put this guy on the number line. So I'm going to pick 2 right here. I substitute 2 for theta into this equation right here, right? So I have 6 times 4 it could be 24 plus 50 it could be 74 subtract 80 it could be negative, right? So this interval is negative, this guy is positive, and this guy must be positive, right? Now the distance between the particle and the pole is increasing. It tells us that dr over d theta greater than 0, right? So it's going to be this interval right here and this interval right here, right? So the answer must be D. Now let's move on to question 21. Which of the following is equal to the area of the region inside the polar curve r equal 2 cosine theta? and outside the polar curve are equal cosine theta. Alright, we need to graph these two guys on the polar coordinate. Alright, now we need to calculate the area of this region. And you know that the circle of the form R equals A cosine theta is fully traced as theta goes from negative pi over 2 to pi over 2. So, we have the formula error equals 1/2 the integral from negative pi over 2 to pi over 2 of outer radius is going to be 2 cosine theta altogether square. Subtract the inner radius, it could be cosine theta altogether square d theta, right? So it's going to be 2 times 1/2 integral from 0 to pi over 2 of 3 cosine square theta d theta. We're going to simplify this one. It's going to be this guy gone, bring 3 to the front. 3 times integral from 0 to pi over 2 cosine square theta d theta, right? So the answer must be A. Now question 22. The area of the region inside the polar curve are equal 4 sine theta. This guy actually equation of the circle, right? And it's going to be vertical circle. And outside the polar curve r equals 2 is given by. Now since calculator is not allowed, you're supposed to know how to graph this guy. Alright, so please check out the link in the description below to learn how to graph this polar curve, right? Now if you graph it, it's going to be something like this. Now we need to find the intersection right here. Right? So we just equate this guy and this guy. So we have 4 sine theta equals 2. Sine theta equals 1/2, right? And theta equals pi over 6, 5 pi over 6, right? This one is 5 pi over 6, this one is pi over 6, right? So the error equals 1/2 integral from pi over 6 to 5 pi over 6 of the outer radius. The outer radius is this guy right here, right? So we have 4 sine theta altogether square. Subtract the inner radius, it's going to be right here, 2 square d theta. So it's going to be 1/2 integral from pi over 6 to 5 pi over 6, 16 sine square theta. Subtract 4 altogether d theta. So the answer must be D. Now question 23. Which of the following expression gives the total error enclosed by the polar curve R equals sine squared theta shown in the figure above? When the polar curve at the origin, the radius equals 0, right? So we have sine squared theta equals 0. It's the same thing as sine theta equals 0, right? And theta equals 0 and pi. The error is 1/2 times the integral from 0 to pi of sine square theta altogether square d theta. This guy is just the upper half, right? We have this guy symmetric about the x-axis, so we need to multiply by 2, right? So the final answer is integral from 0 to pi of sine to the 4 theta d theta, right? So the answer must be D. Now let's move on to question 24. What is the area of the region enclosed by the limit scale r squared equals 18 cosine 2 theta shown in the figure below? Alright, so again, when the radius is 0, the polar curve at the origin, right? So we're gonna let 18 cosine 2 theta equals 0, cosine 2 theta equals 0, right? And 2 theta equals n pi over 2, right? Theta equals n pi over 4, right? So you know that n is the integer, right? If n equals 1, we get pi over 4. n equals -1, we get negative pi over 4. So this guy right here actually negative pi over 4, and this guy actually pi over 4, right? So we just calculate the error of this guy right here, and we multiply by 2, right? So we have a equals 1/2 integral from negative pi over 4 to pi over 4 of this guy square. So we already have square right here, so it's gonna be 18 cosine 2 theta d theta. Now you need to multiply by 2 to get the left hand side, right? And then I need to convert this one to 0 to pi over 4, right? So I put 2 in the front, right? So 2 and 2 cancel out. I have another 2, right? 2 times 18 could be 36, right? So I have 36 integral from 0 to pi over 4 cosine of 2 theta d theta, right? So remember, antiderivative of cosine of as plus b ds is going to be 1 over a sine of as plus b plus c. So keep that in mind. So 1 over 2 is going to be 36 divided by 2 is going to be 18, right? Times sine of 2 theta, right? Evaluated from 0 to pi over 4, right? So it could be 18 times sine. Substitute pi over 4 over here, it could be pi over 2, right? Substitute 0 over here, it could be sine of 0, right? So the answer is 18, right? The answer must be C. Question 25. Which of the following gives the error of the region enclosed by the loop of the graph of the polar curve r equal 4 cosine 3 theta shown in the figure above? When the polar at the origin, the radius equals 0, right? So we let this guy equal 0 to solve for theta, right? So cosine 3 theta equals 0. 3 theta equals n pi over 2. Theta equals n pi over 6. When n equals 1, we get pi over 6. When n equals -1, we get negative pi over 6. This guy actually negative pi over 6. This guy actually pi over 6, right? So the error is 1/2 integral from negative pi over 6 to pi over 6, right? Of the radius square, which is 4 cosine 3 theta all together square d theta. Alright, this could be 1/2 integral from negative pi over 6 to pi over 6 of 16 cosine square 3 theta d theta. Now 16 divided by 2 is going to be 8, right? So we have 8 integral from negative pi over 6 to pi over 6 cosine square 3 theta d theta. The answer must be E. Now let's move on to question 26. Which of the following represent the graph of the polar curve r equal to secant theta? We have S equals R cosine theta, right? But R equals this one, right? So it could be 2 secant theta times cosine theta, right? So it's going to be S equals 2 secant theta is going to be 1 over cosine theta times cosine theta. This cancel out, so S equals 2, which is the vertical line. The answer must be D. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.